after evaluating the discussions from earlier this week on Chapter Review Problems 8.1, I've narrowed it down to reviewing 5 problems that seem to be common amongst the majority of you. So hopefully this will help you in further completing the rest of the chapter review problems. So the first problem was question 31. And you guys can itemize the problems the same way in school. You can underline in OneNote, but however you want to do it is up to you. Can't make you do it any differently, but if you can write on it or do it, organize it the best way you can, go for it. So with my tools, I'm going to use my highlighter. And so the first thing, as always, read the question aloud with your pen down, that Jupiter is 5.2 times farther from the sun than Earth is. Find Jupiter's orbital period. So first thing I want to focus on is that Jupiter is 5 times farther from the sun than Earth. And what we're looking for is Jupiter's orbital period. And a key factor that they do to help you is in Earth years. And I will show you where that kind of comes into play. So we can use the data found in table 8.1, but because we are given data in reference of another piece of information in a problem, we can use that in comparison. So if we want to set up a mini table of data, whatever you want to do, that's fine. It's one thing that I like to do. Well, the first planetary body we're talking about is Jupiter. The second is Earth. And we're both talking about them orbiting the sun. So the radius that Jupiter is going at, we can do it 5.2 times whatever Earth is in the table, but we can just do it in reference of the variable of the radius of Earth. And the radius of Earth in this same designation would just simply be radius of Earth. Then, when we're looking at the period, our unknown is the period of Jupiter, and for Earth, since it's in Earth years, it's just 1 year. And whenever you get an opportunity to put in a unit that is just a number 1, go for it. Always take that opportunity unless it's specified in a problem. Now that we have our data, now we've got to assess which formula is going to be best used here. And Kepler's third formula is the best. So we're going to talk about the relationship between the two periods, the period of Jupiter and Earth. And the reason I'm putting this on top is because that's what we're trying to solve for. And remember that that is the quantity squared is equal to the ratio of the radius of Jupiter over the radius of Earth, and that quantity is cubed. And remember that we got to make sure that whatever planetary body is on top, Jupiter is on top, and planetary body on bottom is on bottom. That has to be consistent. We also can now extrapolate, instead of keeping it in parentheses, that this is the period of Jupiter squared over the period of Earth squared. And this is the radius of Jupiter cubed over the radius of Earth cubed. When we do that, we want to solve for Jupiter by itself. So let's multiply both sides by TE squared. Keep this in the parentheses, TE squared. And now we have the period of Jupiter squared equals the quantity of radius of Jupiter over the radius of Earth, both cubed, times the period of Earth squared. And just remember, all in the end, if we want to reduce this down, we have to square root everything. So now, after we do this, now we just have to sub in. So let's do that. When we sub in, we have the square root of the quantity. We look at the radius of Jupiter cubed, but remember the radius of Jupiter is 5.2 times the radius of Earth. So we're going to put in 5.2 radius of Earth quantity cubed all over the radius of Earth cubed. And then we're going to multiply that by the period of Earth, which is 1 year, quantity squared. Well, we can actually reduce this down because since we have a radius of Earth over here and a radius of Earth over here, they subtract out or cancel out. And so now we have the reduced formula of 5.2 radius of Earth quantity cubed times 1 year cubed, which we know is just simply 1 year. So when we do the math, we're going to get, I apologize, this radius of Earth is already gone, 5.2 cubed, and then we square root that, and we get 11.86 years. So that is problem 31.